This is the lesson for the second side of Handout C. So as again, you can see the problems are numbered here. So 32 right here is similar to 32 in the problem that you'll see on Handout C. So let's take a look at our problem here. It's an addition problem. So with addition, don't change any of the signs. Just rewrite the numbers in that second polynomial underneath the values that you can combine with from the first one, and then combine. And so again, when you see that the signs are the same, you're actually going to add those numbers. So 5x squared is what we get for the first part. 2x and 4x make a total of 6x, and the last numbers, negative 4, negative 8, add to make negative 12. So that would be our answer. Taking a look at the next problem, here we have the sum of two binomials. So this is what they add to equal. And then one of them is this, 2x squared plus 3x. Find the other. Well, here it's just a subtraction problem. 5x squared minus 8x. This is the sum. So the sum is this one. One of those is equal to 2x squared plus 3x. Well, what we're going to do is we're going to take the opposite of these. We're going to subtract this from the sum. So when I subtract, I'm really going to add the opposite. So it becomes a negative 2x squared, a negative 3x. So let's put those signs in there. And then we end up adding those together. And when they're opposite signs like they are here, we're going to end up subtracting. So we have 3x squared, and here they're the same signs, so we're going to end up adding. So negative 11x. That is the other side of, or the other binomial. Taking a look at our next one here, we have a problem in which they want us to factor. And so first thing you're going to look for those common factors. So x squared, x, and then a y and a y squared. Can't take out any variables, but we can take out a 2. So let's put the 2 on the outside, and we do the division. We've got x squared minus 4xy minus, since I forgot to divide there, so let's fix that real quick. So it becomes a minus 2xy and a minus 15y squared. So the part that seems tough is this y squared. Well, let's go ahead and leave the 2 in there because they're not asking us to solve, just factor. And so x and x make x squared. I know y and y make y squared. So what numbers multiply to make negative 15 but subtract to make 2? Well, that'd be a negative 5 and a positive 3. And so if it just has an extra variable like y squared, just put the y next to the constant, and now we have ourselves a term with coefficient in the variable. So that's what our answer is right there. Here, they're asking us just to factor this trinomial. And so when I look at it, it's got x squared minus 2x minus 35. And so when I go ahead and factor this one, it's going to factor as two binomials. And when I look at that, I've got x squared minus 2x minus 35. So I know I start with x and x, make the x squared. And then I go ahead and factor numbers that multiply to make 35 would be like 7 and 5. And they do subtract to make 2, but to make it a negative 2, I need more negatives than positives. So we'll make a minus 7 and a positive 5, and it does end up working out. Well, the next one has an equal sign. So here we're going to solve. And so the way I would end up solving is I would go ahead and factor. So I'm going to subtract that 12 from both sides. I've got 2x squared plus the 5x minus the 12. And this all now equals 0. And so when I go ahead and factor, I'm going to draw two sets of parentheses. And I'll start with 2x and x. Those are the numbers that make that 2x squared. Now, that minus sign right here tells me that the outside and inside terms are going to end up subtracting. Now when they subtract, they're going to equal a 5x. So I need to think of numbers that multiply to make 12, but when I come up with those, I need something to be a little more than 5. And so I'm thinking of maybe like a 2 times by a 4 here. And let's put the 3 here and see if this works. So you see this makes 8x and this makes 3x, and those will subtract to make 5. To make a positive 5, we need to make 8 positive. So there's where the plus sign goes and the minus sign goes on the 3. And so from this point, now we have to solve. So we take those factors, 2x minus 3, we set that equal to 0. And we do the same thing with the x plus 4, set that equal to 0. So when I do this, I do some opposite operations here. So I have to add the 3 to both sides. And then I've got this 2x equals 3. So I'm dividing by 2. And I get that 3 halves as one of the answers. Over here I have to subtract the 4 and I end up with -4 as the other answer. So those are my two x-intercepts. Taking a look at our next one here, we've got a problem in which we could solve by completing the square. That's what they're going to want us to do. And they may not ask us to solve all the way, but we'll go ahead and do that. So -4 times by a half. You always take half the b term, it makes -2. So then we have to take that -2 and square it, because we need to figure out what two numbers we have to add to both sides to make a perfect square trinomial. And the reason is that when you come up with the factored form, which is the x minus 2, the numbers that half of the b term is always inside what's inside the parentheses. -2 and -2 add to make -4, but they multiply to make a +4. And now this all equals 10. And so from that point, all you have to do is take the square root. And then we have this x minus 2 equals plus or minus the square root of 10. Well, all we do from that point is just add the 2 to both sides. And so when I do that, and again that square root symbol is still around that 10, because I have not taken the square root yet, and so now I have x equals 2 plus or minus the square root of 10. Well, looking at the next one, a little bit tougher problem because of the 3. So what I'm going to do is I'm going to take half of the b term, and that makes a fraction, 3/2. And I take that number and I square it. And so when I square 3/2, I get 9/4. And that's what I'm going to end up adding to both sides. So this method is difficult when we've got odd numbers as the b term because we have to deal with the fractions. And so when we add these two numbers together, I have to come up with a common denominator. So I'm going to multiply that 4 by 4/4. And that will give me 4 or 16/4, which I can now add to the 9/4, which gives me 25/4. So that's what I get when I add to both sides. Now let's go ahead and factor it. X plus 3/2 quantity squared equals, and then I have 25/4. So I'm going to go ahead and take the square root of both sides, and that'll cancel out that squared symbol. Leave me with this x plus 3/2 equals plus or minus the 5/2. I got that by taking the square root of 25 is 5, square root of 4 is 2. From this point, all you're going to do is move that 3/2 over by subtracting it from both sides. So take that away, take it away from this side, so take away 3/2. And we now can set up our two problems. So we got 5/2, take away 3/2. And we've got -5/2, take away 3/2. So that's how I'm getting 2/2, which is 1. Over here I get -8/2, which is -4. So those are my solutions. Well, the values of x when y equals 0. The zeros is another way they represent that as an answer, or just x-intercepts. So number 39 is another one that asks us to figure out a step in using the quadratic formula, or coming up with the quadratic formula from completing the square. So we'll go through that proof once more. And so we'll go ahead and first start with our quadratic equation in the form of ax squared plus bx plus c. So the first step is to subtract that c from both sides. So when you do that, our new problem would be this: ax squared plus bx equals -c. So from that point, now we need to get rid of this a term. So we're going to divide that entire equation by a. And so our new equation now is x squared, so no more a there, plus b over ax equals -c over a. And so from this point, now we're going to do some work with that b over a. We're going to figure out what it is we have to add to both sides. So what we do is we take that b over a, just like we did with the 3 here, we multiply it by 1/2. And we have b over 2a now. b over 2a. Well, we're going to take that b over 2a and we're going to square it. So b over 2a, we square that term, we end up with this b squared over 4a squared. See, b being squared is b squared, 2 squared is 4, a squared is just a squared. Well, that's what gets added to both sides. So we add that b squared over 4a squared here, and I'm going to add that b squared over 4a squared on this side. So let's go ahead and rewrite our equation in that form. So now our new equation is this: x squared plus b over a x plus this b squared over 4a squared equals negative c over a plus this b squared over 4a squared. So now what we want to do is come up with a common denominator so we can add these two fractions together. Well, you see, this is just a. We're missing another a and a 4, so that's what I need to multiply by, 4a over 4a. And so at this stage, let's go ahead and factor this trinomial, put that over here. So whatever we have for half the b term, so it was that b over 2a, it goes inside the parentheses. See, b over 2a plus b over 2a, those add to make that b over a. And b over 2a times b over 2a makes the b squared over 4a squared. So that's my quantity being squared, equals. Now, when I multiply this, I end up with this negative 4ac, and it is being added to b squared. So b squared, I'll put that first so I show the minus sign in between the terms. So b squared minus 4ac, that's what I get when I multiply these two terms here. 4a times negative c makes the negative 4ac plus the b squared. So I just wrote b squared all over the same denominator, 4a squared. Well, from this point, just as we had done over here, we're now ready to take the square root. So we take the square root of both sides, and what that'll do is it'll cancel out that squared symbol. So let's rewrite our next step here. So now we've got this x plus b over 2a equals plus or minus the square root, big square root symbol, b squared minus 4ac. See, I couldn't take the square root because I can't take the square root of a and c. So I just need to leave it underneath the radical, but I can take the square root of 4a squared. It just makes 2a. And so from this point, I'm going to go ahead and move that b over 2a over. So I'll subtract that from both sides. And so notice at this stage, our denominators are the same, so we can just write it as one fraction now. And so when I do that, I've got x equals, and I've got this negative b, so this minus b first, and then plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula. It's the proof of by completing the square. So those are the problems you'll see on tonight's homework. Good luck.